right, folks, one last time here at Hall 6. For our next speaker, I actually need like a fully written sheet of paper to remember all the things I can say about him. So first, let's start off. He's a fellow community builder, which I much appreciate. He's a former TOC member of the CDF, the Continuous Delivery Foundation. He's a CNCF ambassador. He's one of the core maintainers of Jenkins. Anybody know Jenkins? Yeah. He's holding a PhD from the University of St. Petersburg. He's probably one of the smarter guys here in the room. And well, I guess. And he's a lead developer advocate at Gradle. Please give a hand for our last speaker in this room, Oleg Nenashev.
Thank you. When I speak about Jenkins, I also say probably I'm also a mother of dragons because I created maybe 30 plugins, etc. But I have to say that today's talk has nothing to do with Jenkins. It's a good question. What has to do with? Who is a Java developer in this room? Quite a lot. So thanks a lot for coming. And yeah, my idea for this talk is to show a few slides and to show some examples of how you actually can do observability for Java applications. To some extent, this talk is not very specific to Java 2 because you may experience similar issues with any sophisticated build toolchain and frameworks. But still, I want to show some demos. OK. Who does already run OpenTelemetry with Java? Just a few people. So yeah, hopefully it will be interesting. But yeah, just a few keywords. But really, what is the idea today is to show principle, some examples, and nice demos. I have a lot of slides. All slides are open source, published, so you can watch them there. I won't be spending too much time on them. And I hope you will enjoy live part. OK, so actually, I started working in observability in 2009 before it was a thing. And I had a true Russian observability project, which is monitoring of oil flow with help of X-ray spectrum analysis. And yes, it was called observability at that point. So no, it's not the tech who invented this keyword. And yeah, if you talk more about technical side, of course, for me, observability has started with Jenkins, because when you maintain big Jenkins installations, it's always a problem to understand what the heck happened. So if you're basically with Kubernetes, it's the same, right? You have a big distributed framework, which is basically a huge operating system with a lot of capabilities, and you never know where the things break. And for that, of course, we need some observability just to understand where the things went wrong, what you need to change, what you need to update, or troubleshoot. And now, CI/CD observability actually becomes quite a popular topic because our pipelines become more complex. We introduce more tools, more integration testing, and of course, it implies that there are more and more dependencies. There have been quite a lot of different discussions. We actually started speaking about that with Dotan, with other people years ago. And you probably know that Dotan made a proposal for CD events integration in OpenTelemetry as a part of specification, specifically to help with CI/CD observability. How it used to work in principle, everyone uses OpenTelemetry to some extent. And the idea is quite simple. If you have multiple tools that call one another in the various build chain, you can probably connect them and have these trace that would include your whole pipeline, right? So we start, let's say, from Jenkins, and then Jenkins triggers Maven build for Java. And it can be still a part of the same trace with observability metadata. And it's a really nice thing to have if you can actually get it. Do you have it for your projects? No. Even if you use OpenTelemetry for Java projects, if you have some observability, most likely it doesn't really happen in a real project. And there is quite a lot of reasons for that. And the biggest reason is, of course, the data ingestion part, because it's complex. It has a lot of things. It has a lot of tools. And many of these tools still have no idea that it's millennium already, and there are some things like OpenTelemetry, right? So you have bash scripts, you have some analysis tools that were created long ago. If on the front-end side, yeah, we have OpenTelemetry, we can connect it to multiple services, we can do all the analysis, cloud automation after that. That part is quite sorted in the CNCF. Under the hood, yes, there is a lot of tools, and each tool basically operates separately. Many tools are quite legacy ones, and even if in principle it's just install OpenTelemetry agent and integration, and you get it working, in practice it creates quite a lot of complications just because there is a lot of tools. Going specifically to Java space, again, it's quite difficult to troubleshoot what happens. Oh, it's huge. Yeah, but yeah, so basically Java, as any other framework, it operates on many levels. Actually, even if you want, you can even do configuration management and infrastructure as code with Java. There is Pulumi and SDK for that. But for simple projects, you have pipeline, which is defined somehow. Then there is build tool. In Java, it would be mostly Maven or Gradle. Then it would be your favorite framework. Maybe Spring, maybe Quarkus, but it's still an item you put in your chain. Then it will be JVM. Again, your is here for the reason, because every item you take may have so many flavors depending on the company, depending on your culture, technology stack, and there is no universal solutions for them. And then we finally end up with operating system and then test frameworks, etc., that also have quite a lot of infrastructure. So if you want to observe your build pipeline in continuous integration, you need to do all of that. If you speak about continuous delivery, it becomes even more interesting. But let's stick to CI for now. So for all the steps, we need to add some observability. And actually, there are solutions for that. So I want to just show you some tips. I have a demo. This demo is in public repository. And there is some plot twist there, because it has two parts. Yesterday, we had a discussion, and I was told that basically everyone already does Argo CD demos, etc. So maybe at this conference, it would be interesting to do something else. And then I had a discussion with my Kubernetes cluster that said it doesn't longer want to run any new containers. So today, I decided to try something different, specifically for this demo. Instead of using Kubernetes cluster, etc., I want to use public services, SaaS. So there are quite good cloud-native build engines. Let's say GitHub Actions. It's actually cloud-native. We can try it. And the same for observability. In my case, I decided to take Honeycomb. So if you want to just take this demo, you can download it, you can put your application keys, and in principle, it should work. And I want to focus on the steps that so basically, I started setting up this demo yesterday. So this is where you can get probably after one working day of average, not so experienced OpenTelemetry developer. And let's see how it happens for the Java side. So first item we would need in our stack is, of course, our pipelines. And as I said, we take GitHub Actions. Who has ever tried OpenTelemetry with GitHub Actions? Yeah, because supposedly it should be a click a button like in other CI systems. In Argo CD, in Jenkins, you install a plugin, do some configuration, and it works. Apparently, in GitHub Actions is not exactly like that, because first of all, our awesome community created quite a lot of different OpenTelemetry integrations already. So if you just Google for OpenTelemetry, you have 10 results. But it's just a tip of the iceberg, because there are many other tools and systems that integrate GitHub Actions with OpenTelemetry. And these actions, again, they can be vendor-specific. Others are just created by somebody who assembled things together for all the GitHub Actions APIs, etc. So it takes some time to even find something that works. In my case, yeah, there are a few examples. So as I said, I use Honeycomb. So there is Honeycomb events. And this is the reason why it wasn't even found in OpenTelemetry search, because it has no OpenTelemetry reference here. And yeah, then there are some OpenTelemetry setup things, trace actions. And let's see how it looks in practice, because in practice, it looks horrifying. So, because GitHub Actions is a cloud-native service which you cannot really influence, so you cannot set up agent on the GitHub Actions, right? Even in GitHub Enterprise, you can do some external things over webhooks, but you can't really instrument the things like you would normally do with OpenTelemetry. What people do instead, they set up some scripting and configurations. Is it visible enough? So here's a GitHub action. Again, it's just a common CI pipeline. And here we include some environment variables, like, of course, we need to report to Honeycomb. There are some endpoints that we need to specify, so like in any OpenTelemetry collector. And then, basically, we start setting up things. And here, so first of all, we set up environment. And for that, again, there is a GitHub action that configures everything. Then, it's not enough. We also need to set up telemetry because we need a first step. So at least we could assemble all the spans in a single trace ID. The trace ID is created here. And it's not even put in the environment probably in GitHub action. It's just a variable you can reference. Then you set up additional telemetry item. And then basically you have other setups happening. We will get to that in the future. But then, after the end of execution, you also need to export job telemetry. Because again, there is no runtime OpenTelemetry reporting in GitHub Actions that would be available out of the box. If somebody is willing to build it on the top of webhooks, etc., it would be awesome, or maybe GitHub app. But at the moment, you have to basically report post factum. And it already breaks a lot of ideas of our CI integrations, like how we can build a trace when a chunk of the trace on the top level doesn't even exist until the build completes. And well, the result is that you actually cannot. So I'm going to jump between the demo parts, but yeah, what I'm going to do here, I'm opening my recent build for this pipeline, and here we just can find our OpenTelemetry traces on Honeycomb. Again, you can use any other service, Datadog, Dynatrace. It's not very specific here. And what we can see for this execution is that, so I did a test run just before the talk, so it's here. And so what we can see that there is actually quite a lot of traces happening. So you can see that there are multiple traces. There is no integrated one. And where is our pipeline? Our pipeline is in a separate trace, which is called build. And here, you can basically see all your GitHub Actions execution as it would happen. The problem that it gets reported post factum, but still you have all the insights, environment variables, etc. So you can troubleshoot your execution pipeline here. Is it big enough? OK. Yeah. So basically nothing specific. All the metadata, all the items are here. So we get our pipeline. What happens next? We actually need to build our project. For that, if we go back to the code, to our definition of the CI system, of the CI workflow, what we will be doing there, we will check out sources, of course, and then we will set up Gradle. Gradle needs additional environment, etc., build caching, so it's integrated into setup Gradle step. We do not have to do it here. And then we basically execute build with Gradle. So here, the interesting part starts is this vast amount of environment variables. And for that, the reason is quite simple. There are so many frameworks. All of them have some integration with OpenTelemetry, but this integration is not unified. So it's not enough to just pass trace ID and span ID as we would hope in our, and as we normally do in our scripts. Because everything is in Java, everything executes in different processes, you actually need to figure out for every tool down the line that is being invoked, you need to do some parameterization on the top level. So here we have this built with Gradle, and yeah, quite a lot of the things. But what does it use under the hood. As everywhere, there are OpenTelemetry plugins. So in Gradle, it was created by Craig Atkinson. So I will just take a link from here, I guess. Oh, yeah. So there is an OpenTelemetry plugin. There is no magic there. When we execute, Gradle itself is a distributed automation engine, and it can have multiple targets and instruments for OpenTelemetry for both build and test. And you can just include a plugin for that. So if I go to my build definition in Gradle, it will be exactly the same as in Maven. So here, once the plugin is installed, so let's see what is our definition. So yeah, there is Quarkus OpenTelemetry plugin, which we use down the line, and there is also Gradle plugin, which is OpenTelemetry build. So we actually include even OpenTelemetry runtime twice in this build. And after that, here we have just some definitions where we basically say service name, endpoint, headers to include, etc., etc. So we have to duplicate everything. Everywhere, and one thing that we have to pass it on our own, because tools still do not know what is trace ID environment variable is. And basically, we have to pass it here. And then, if you do it, you again get a separate trace. So let's go back to our instance. Where is it? Yeah, it's here. So, and again, we get a separate execution that is demo build. And here, again, we get yet another pipeline. So the specifics with both Gradle and Maven, and that this execution is not deterministic because there is a lot of caching involved. Some targets are built or not. So basically, all classic OpenTelemetry metrics reporting doesn't quite work out of the box. But still, you can get this pipeline. And here you pass from execution itself through all targets, like processing resources, generating the build tree, and finally, it will even compile the thing and do the tests. So as we would normally expect in the trace for Java build, we get the steps here. The thing with these steps is that metadata is still quite limited. Because we need to connect test tools, GVMs, etc. And for that, there is a next level that would be actually your framework. So in this example, I have Quarkus, and it's basically the same. So there is a lot of Java frameworks, and all of them have some OpenTelemetry integration. And actually, this integration is the same. I like Quarkus because it's modern. So supposedly, for OpenTelemetry, it works better. And there are good things, because OpenTelemetry is actually a part of default Quarkus distribution. It's a separate plugin, but it's tested with everything else. There is quite a lot of guidelines. There is just one plugin integration that actually just works. So it's a good thing compared to what we had, let's say, on GitHub, compared to the GitHub Actions level. And the idea here is also quite straightforward. You can just configure OpenTelemetry as a plugin in your configuration. In Quarkus, there is some specifics because it can operate differently on developer environment, on the test environment. And in your application, you would need to do some additional configurations. So what happens in my definition? I, again, configure Quarkus here. So in my case, there will be just some environment I pass on the pipeline level. There is almost no changes here because Quarkus operates via environment variables. You cannot really configure Quarkus telemetry from Gradle plugin at the moment, apart from setting environment variables here, like this injection. So in my case, I did it in a workflow, and what we do after that, so it's here. So we can just go to the Quarkus level. And again, there is a lot of application properties that configure observability. So here, there is application name, OTP traces, everything we saw before. We just have to copy-paste it again with Quarkus formats here. And after that, you also get this part of execution. For both tests, etc., they get integrated into our trace. And in this case, yeah, I was actually able to get a Quarkus thing right inside the trace. So we invoke Quarkus tests with all the environment, and they get injected with metadata here. That's a good part, but if you do some additional things like developer testing, etc., you will have to reconfigure it. But thanks to profiles, it actually becomes relatively easy. Still, it doesn't give you full observability because there are more levels, like JVM system. I do not want to spend much of your time there because for JVM, there is Java Flight Recorder, which is for modern versions of Java, actually provides all the observability that you just need to connect. And for connecting, again, it's relatively straightforward because there is OpenTelemetry Java agent that you can just install on the top of your instance, and it will be collecting all the metrics from your setup. So again, it's a part of supported by OpenTelemetry project. And what you need to do to connect it, etc., like classic Java agent, you need to put it in the environment. So you cannot just install a plugin for that to retrieve these metrics. So again, we go through all this loop, reconfiguring everything just to add this part to the lower level. So here, for example, I download the OpenTelemetry agent somewhere from the internet. Yeah, no version checks, no checksums, etc. Please do not do it in production. And then, again, we just go through all these steps again. For example, here in Gradle build definition, again, I will need to configure this agent because it doesn't just work automatically. So in my case, I want to get some metrics for tests. And I basically consider, again, we pass trace ID, span ID, because apparently there is no magic that would go there. And you also configure a lot of environment variables here just to get them running. And after that, yeah, it will work. So if you go to our honeycomb instance, again, after the execution on pipeline, maybe I will just launch something while we speak. So that part is easy. We just let's break test, okay? So for, while we are talking, we can just say that okay. So it's just a Quarkus test that verifies response of the mock instance. It's not very specific here, and yeah. Yeah, who doesn't need commit messages, etc. So yeah, this is a typical Hacktoberfest pull request, right? So let's see how it goes. And meanwhile, let's return to this instance. So basically, if we put all the data, if we get these traces, you can see that I keep getting like that. So for example, I have output for the build. I also have some outputs for the tests, etc. And it's, yeah, it has been a while. And basically, the problem is that I was unable to actually connect even everything into a single trace, even with GitHub Actions, which should be quite straightforward. So there are reasons for that, like GitHub Actions itself is synchronous. There are multiple frameworks. But basically, this is a state of observability for CI/CD, specifically for Java. Unfortunately, it's more or less the same for all other build tools at the moment, because there is not enough integrations, and there is a lot of different gaps here and there. And if you go through the, for example, if we had real cloud-native system with continuous delivery, if we had testing in containers with multiple tools, we normally use test containers, local stack for integration testing. You can deploy everything in K3s. And basically, it becomes a real challenge to balance everything because there are all these gaps here and there. And the problem for the ecosystem is that it still needs quite a lot of investment to actually handle the things. There are new projects like CD events, there are standards being introduced, but still we are missing this simple, let's say, like in Golang, you mostly can get away with trace ID and span ID unless you do distributed builds. So for Java, it's also something that we want, and it's also something that needs to be done. So in my case, I wanted to show it to you. Actually, it works better with Argo CD, but the principle is the same. Modern observability for CI/CD still needs to be done, and the biggest part is here. There is quite a lot of integrations that are missing. There is quite a lot of scripting. There is quite a lot of passing variables here and there where you miss metadata if you don't configure it properly, where you just can, say, send trace somewhere completely different location. And unfortunately, this is a part where you which you have for pretty much every build. You have to figure it out on your own, and it's definitely not something we would like to do. So my takeaway for you, if you expected a talk where everything magically works, it's not. If you ever want to do CI/CD observability, prepare that it will require a significant investment, and for this investment, definitely we need more investment for the ecosystem. Definitely in your projects, open source or not, consider adopting open standards, because once you have them, at least some level of this complexity and integrations can be removed. Because OpenTelemetry standard, if there is standard metadata interaction through environment, etc., then it becomes easy. And another thing is, of course, combining tools for different levels, because most likely for your project, whether it's Java or Python, you already have a nice tool for domain-specific analysis. So until there is OpenTelemetry standard, let's say specifically for JVM operations, probably you do not need OpenTelemetry for JVM operations, and instead of that, you need to combine the tools and cross-reference them. So this would be basically my recommendation for you. There are quite good Java tools with JFR, with JMX, and at the moment, for Java observability, it's better to use them and connect OpenTelemetry on the top level on pipeline, where it actually started working now. So I know that it's not a success story, and it wasn't intended to, but hopefully it at least provides some insights on how real observability works for Java these days. Okay.
Perfect timing, so I think we still have time for some questions. Please raise your hands if you have questions. Four,
Okay.
3, yes.
We need to speak about Jenkins. Would it have been...
It's unavoidable to talk about Jenkins. Would have it been better with Jenkins in terms of observability?
To some extent. Tools like Jenkins, Tekton, and Argo CD, they have access to the runtime. So you can extend them. You can properly connect OpenTelemetry, at least on the runtime side. The problem is that still passing the trace through all the execution would be complicated. But at least on the top level, you have foundation trace that starts being created in the beginning of the build. So if you do it properly, you can do it. But for each call between the tools, let's say you have some bash script or Helm chart that triggers something under the hood, you will still need to pass the metadata. And specifically for Java projects, at the moment, there is no universal standard for that. So I'm pretty sure that you will get to the same issue on lower levels for complex tools. Just Maven build, yeah, it works pretty nice.
Thanks.
Mm-hmm.
Any other questions? Yes, over there, I think.
I know it's a bit stupid question, but I know that observability is important for clusters, important for the CPU resources and all of that, but when I look at the observability of a Maven build, for example, it's just this stack trace, like, I know it's stupid to ask, but this stack is always there in the console. When you have a problem, you will always see the large, ugly stack of Java errors, but I want to know, why would I need this trace for that part exactly?
So first of all, performance. if you talk about the build with modern framework, that includes quite a lot of different targets, quite a lot of dependencies, you still want to troubleshoot what happens, firstly in terms of performance, and then you need to capture timestamps, you need to discover where actually you have some delay, then optimize. It's one part. Another part is actually when things break. OpenTelemetry allows you to actually trace execution down the line. For example, how you pass environment variables, how you pass Java properties, what is the state of the system. So assuming that you have all the trace of execution, this information can be used by tools to actually guess what really happens. If you have ever used Gradle, you know that sometimes it's difficult to understand what actually triggers the error. And things like OpenTelemetry or existing integrated observability like Gradle builds can actually do that by going back to the trace, and all this metadata is a source of information for this analysis.
All right. Do we have one final question? 3, 2, yes, over there.
Yeah, maybe a bit of unrelated to this topic, but I'm coming from the Spring ecosystem, and I've never had to do anything with Quarkus, so I was wondering if you have the high-level overview, what the main difference is, what different use cases you would use it for, what are the advantages of Quarkus over Spring? Thanks.
Yeah, this is a good question, and there is no universal answer, because Spring keeps evolving, and Quarkus keeps evolving. At some point, Quarkus was created like a developer-first framework with developer experience being provided out of the box, with a lot of things like live development being integrated, or later dev services that would allow you to quickly test the environments. This is why Quarkus was created. And what happens next? A healthy ecosystem like Spring, they adopt the same features. So at the moment, let's say, choosing between Spring and Quarkus, there is no universal answer. If you already have established Spring and team that is experienced with Spring, most likely you will never move to Quarkus. But for a greenfield project, it's actually a matter of choice and curiosity and some particular integrations. So basically, that would be the answer. Frameworks, yeah, they mimic each other.
All right. Okay, final question here.
Yeah.
Are there any performance benefits from Quarkus when it comes to distributed system as compared to Spring, or?
In theory, yes. In practice, I would say it's inferior to all the migration cost. So if somebody implemented a real system that runs on both Spring and Quarkus, that, for example, both would be highly optimized, built to native images, because with Spring it's also possible these days, then we could probably discuss it. At the moment, my take is that the performance, yeah, it needs to be measured, but in every system, it will be quite good if you design it properly. I would assume that in some cases, Quarkus will be much faster because it's new, lighter framework. But maybe in 10 years, Quarkus, I'd say, will have the same performance issues as Spring these days.
Thanks.
So,
All right. Thanks for the
we need
talk.
to test.
So thanks for the talk. Thanks for the answers and the questions as well.
Mhm.
Since now we're approaching the final stage and the final event of KCD Austria 2024, I ask you to leave Hall 6, hand over or go over to Hall 4 for the final event. And when you go outside, grab a gummy bear. We still have lots of them left. Big hand of applause.